So in this video I will be discussing Codeforces round 938 rated for division 3. So I will be solving first 5 problems in this problem set A to E. So let's start with problem number A. The name of problem is yogurt cell. So in this question I will be given a number, for example, and it will define a one yogurt, and I will be given a cost of that yogurt, that is A Burlis, and also I will be given a promotion deal. For example, in this for example we can state that two yogurts can be bought with B Burlis and one yogurt can be bought with A Burli, and we have to find the minimum number of costs in which we can buy exactly n yogurts. So it is a pretty much simple problem. Like if my cost of two burleys is greater than if I buy the independent one piece, then I can simply multiply n with a and find the answer. But if it's not the case, for example, my cost of like one yogurt is like 5, and my cost of two yogurts is 6. So it's definitely beneficial for me to buy the two yogurts for 6. So I can buy that in that way. But there is also case like if my n is a odd number, then after buying the yogurts in the set of 2 to 2, I have to also check whether there is whether my n is odd or even. If it's an odd number, then I have to also add a burly to my number. The code is also pretty much simple, like you can see here. uh, like if my 2 into a is smaller than b, which means it's beneficial for me to always buy independent yogurt. So I can simply return the n into a, and that's the answer. But if it's not the case, what I can do, I can simply find the cost by multiplying n by 2 into b. But if my n is a odd number, then I have to also add a cost of single yogurt which I have to buy, because they have said that I have to buy exactly n yogurts. So that's why I will simply add the a in my final cost. So that's how you can find the cost of this answer of this question. So let's now discuss the problem B, that is progressive square. So it's a pretty much difficult to understand the problem in the first glance. So I will tell you in the here. So for example, like the question will give you some like 3 parameters. For example, like first is n, second is a, and let's suppose third is b. So let's suppose my first number is always like, so suppose my first number is b, 1. So my next number, and there's a matrix of n into n. For example, in this case, let n be equal to 3. Okay, so so n into n matrix will be constructed in this question. So what is the next number of 1? The next number of 1 would be plus b. For example, 1 plus b, that is equal to, let's suppose here in this case my b is equal to 2 and my a is equal to 3. So in this question my next number of a would be 1 plus 2, that is 3, and 3 plus 2, that is equal to 5. Okay, but if I want to go downwards, then 3 will be plus, because my a is 3. Then 1 plus 3, that is equal to 4, and 4 plus 3, that is equal to 7. And if I'm going from left to right, I will simply add b in my answer. So b in my array, for example, it is 4, then 4 plus 2, that is equal to 6, 6 plus 2, that is equal to 8. Okay, done. Now here it's 7. 7 plus 2 is equal to 9, and 9 plus 2 is equal to 11. So that's how you have to construct a matrix. So in the question, this is not a given. In this question, I will be given a shuffled array of all these numbers, which means if you are given n, then an array of n square will be given to you, and that will be in shuffled order. So you have to tell whether it is possible to construct a matrix like from a and b to from the shuffled array. So there's a one observation in this question, like my minimum like my minimum element in my array would be always be at 1 comma 1. So that's how you can construct this array also by adding the b in the horizontal wise, and by adding the a in the vertical wise. So first of all, construct this array. Okay, now try to verify from the given set of array which you are given by the problem. Like for example, in this case, this is my answer. So what I'm doing, I'm simply sorting the all my sorting my a. Okay, then I'm finding the minimum number, that is b, a of 0. Then I'm constructing my own array. Okay, then I'm constructing my own array using the minimum element. Okay, but how I can construct? I can simply construct by from a and b numbers. Like if I'm going from left to right, I will simply add my second number. Okay, if I'm going downwards, I will simply adding my first number. So that's how I can construct. So what I'm doing, I have simply constructed this array firstly, this 2D matrix firstly. Now what I'm doing is simply verifying whether all these numbers are present in my array which is given to me or not. If it is there, then I simply put yes. If my sum of the number is not present in my matrix or in my even my given array, and it is there in matrix but not in the given array, then the answer is definitely no. So I simply print no and return from here, else print the yes, and that's how you can solve this problem also. So this is also pretty much easy. So let's now discuss the problem number 6, that is inhabitant of the deep sea. So what's the problem is saying? So in this question I will be given let you repeat. For example, there are n ships set out of the so let's suppose there are n ships which are there for exploring the ocean. Okay, and I am giving a ship from number 1 to n. Okay, in the ascending order. Now you know, like there is a carcane. Like if you don't know the what is a carcane, it has a some sort of moisture, sea moisture. Like you can say in the term of code forces. Like what he will do, he will simply attack the K ships in a specific order. Firstly, he will attack from the firstly he will attack the first ship, then the last ship, then the first ship, then the last ship. Okay, but this monster has a suppose this monster will attack only K times. Okay, let me tell you here more clearly. Like for example, if you are having ships like 5, 3, these are the damage capacity of my all the ships, like 3, 1, and there's a monster which is having a attack capacity like suppose 7. Okay, then how the monster will attack? He will firstly attack on the first ship. Okay, then it will be decreased by 1. Okay, great. Now it will become 4, and it has also decreased to 6. Okay, now he will attack the last ship, that is equal to 1, then it will become 0. Okay, great. Now my 6 is, now 6 will also boil down to 7, 5. Okay, now 5, now now he will again hit the first hit, and it will also decrease to 3. Now he will now decrease, now he will not hit the 0 because it is also always been it's been destroyed, so it will hurt the, or it will damage the this one ship which is the next to my last ship, that is equal to 3. Then it will decrease, for example 3, it will now become to 2. Okay, okay, yes. Now what you will do, now my attack power will also be decreased. So in the similar way, first and the last ship, first and the last ship, first and the last ship. So that's how my monster will repeat my attack process. So you have to tell them what are the number of ship which are being destroyed at the end of my attack power of my monster. So how you can solve this problem? But there is a catch. Like my number of power can be equal to 10 to the power 15, and my each of my damage power of my ship can be equal to 10 to the power 9. So you cannot simulate all the process because it will definitely give you time limit exceed. So how to solve this problem? Like there's a pretty much good observation for this problem. What is that? So let me tell. Like for example, if you are given a ship like 2 here and let's suppose 3 here, there's some random stuff here. I'm not caring about it. First of all, I'm only caring that first and last ship. So what is the maximum amount of what is a suppose, let me tell you, uh, let me consider a case. Like my let turn of my monster is on the right hand side, which means, or let me take it here only. For example, my monster will hit the first ship firstly. Okay, now what is the minimum number of, let first of all find the minimum among these, because that is the first ship which will be destroyed among these two. Yes, so first of all find the minimum ship with the attack power with the ends. For example, I and J, what is the minimum ship among these two? So that is 2 only. So okay, that is 2 only. So now what is the minimum amount of attack required to destroy the minimum required damage ship? So what is that? For example, this is equal to 2. So what is the minimum amount of damage attack required by the monster to destroy this ship? That is definitely equal to 2 into 2. 2 into 2. Because why? Because if he is hitting in this ship, then in the next turn he will not hit this. He will hit the ship in the last manner, which means this part, then again this part, then again this part. So that's you can prove that the to kill the ship with the minimum damage, the minimum amount of attack required is 2 into minimum of both of them. Okay, so but this is not valid in all the cases. Like if you have observed in this case only, there is a catch. For example, let's suppose there is equal to that it is equal to 4, and my first number is equal to 4, and my last number is equal to 7, and the first attack is here only. Okay, now what is the minimum amount of damage required? That is not equal to 4 into 2, but it is equal to 4 into 2 minus 1. But why? Let's suppose he is hitting here, it will become equal to 3. Now hit here, now it will become to 7, 6. Now it will again hit 2, and then equal to 5, and then equal to 1, then equal to 4, and then equal to 0. So how many steps required? Total number of 7 steps which I have repeated. Okay, because this is because my first attack is on the first chip, which is minimum also. This is giving me advantage of -1. That's why I'm doing a -1 here, because my first chip is minimum, and that's where my moisture is start hitting. So this is the first observation. Like if I show the code is pretty much self-explanatory. But why? Let's suppose what I'm doing here, I'm simply maintaining the two variables I and j. My I is the first variable or at the first point, and my j is the last, my j is the last pointer. So and count is the number of ships destroyed by the moisture. Okay, so what I'm doing next is that I'm finding the minimum of the both of them. Let's suppose my minimum of first and last ship is TP, or I can define the minimum to be destroyed, that is equal to TP. Okay, yeah, I can handle the I is equal to JK separately, that's why I'm doing it here. But now let's back to the original problem. It is my TP. Okay, now if my let's suppose I'm taking a case. Let's suppose my minimum ship, let my left number of attack is greater than 2 into minimum ship, which means I can either destroy the first and last also. That's a case. Okay, for example, if it is equal to 2 and it equal to 3, then I can destroy 2 properly. And if my number of attack is greater than 2 into 2, that is equal to 4 only. If my attack is greater than 4, I can destroy the minimum ship. That's for sure. So that's what I'm checking here. If my number of attack left is greater than or equal to 2 into minimum ship, then I can definitely destroy the minimum ship. Okay, that's great. So what I'm doing, I simply subtract my minimum attack from my both of the ship, that is first and the last ship. And the first ship to become equal to 0, that pointer I will increase simply. That's the solution. Because if my first pointer is decreased to 0, then I will increase my I, increase the number of count of the destroyed ship also. And if my j is equal to 0, then also I will increase my number of count by 1 and decrease the j also. Okay, next what I'm doing, I have to also decrease my k, because that much amount of energy is being used by the monster to killing the ships. So I have to decrease that also. But there is also case which I have told you earlier, because in this case, if my if my first ship is like 2 and my last ship is 3, then the minimum number of and let's suppose I'm taking like here, let's suppose my this is 3 and this is 2. Okay, now to kill that second monster, now to kill this ship, and you are starting from this, which means my monster will start killing from this side. Then the minimum number of attack required is minimum into 2, that is 2 into 2 in this case. But if there is a case like same, taking the same case, that 3 into 2, but in this case my I will start attacking from the last ship itself. So in this case, if I start attacking on the last ship, then it is not equal to 2 into 2, but is equal to 2 into 2 minus 1, because I'm getting advantage from starting from the minimum number itself. That's what I'm trying to say. Okay, so if my required number of k is smaller than or equal to 2 into minimum minus 1, then what I'm doing, then I can simply check, then I can simply increase my count and break it here also. And my a of I is equal to minimum also, that's also condition, necessary condition. So that's how you can solve the problem with C also. It's pretty much greedy only, but just you have to check the first and last pointer, and what is the required number of attacks required to kill the minimum from both the left and right. And if at any point you are ready to kill ready to kill a ship, and in that case you can simply change the pointer of that corresponding ship and simply decrease the k. Don't forget to decrease the k in each and every case. And the last pointer you have to also keep in mind of 2 into t minus 1, because if the minimum is getting advantage of hitting first, then the required number of attack is only 2 into minimum minus 1. That's a crucial condition for this. So that's how you can solve the problem with C. So let's now discuss the problem with D, that is inaccurate subsequent searches. So in this question I will give you an array of n size and an array b of m size, and definitely my m should be smaller than or equal to n. So there's a condition for array C to be good. And what is that condition? The condition is simply that my at least my k number of elements from a C should match with element of B. So that's the condition only. So in this question, let's suppose you are giving an array A and array B. You have to find each and every subsegment of size m in array A and check whether that subsegment is a good or not. And how it is good? If it's matching at least k character from my array B. So that's the definition of my good subarray. So how to solve this problem? So it is a pretty much sliding window type problem, but how? Let me show you. For example, let me take this case only. Yes. Okay, so I'm taking this as case. So in this question, what are the number of good subarrays? I will start from middle. Let's suppose my this is equal to my size of m is equal to 3 and my size of m is equal to 5. Okay, so for each and every subarray of size 5, I will try to compare at most 3 numbers whether they are matching or not. So in this question, so in this subarray, whether my 3 numbers are matching or not, I will try. My 10 is 10, my 10 is matching. Okay, great. My none of the number is matching now. Okay, so I will not take this. So let me now increase my subarray. Let's suppose it is equal to 9. So here 9 is cutting, here 9 is cutting, here 9 is cut. Okay, my 10 is cut, my 10 is cut. But my any of the number is cutting? No, my none of the number is now cutting also. So let me increase my subarray. Okay, let me now uh, take this subarray. Now my 7 is matching, my 10 is matching, my 10 is matching, my 9 is matching, my 9 is matching. So I will not try to match further because my 3 number are already matched. So it's a good subarray. So that's how you can compare. So similarly, you have to compare with this subarray. You have to compare with this subarray, this also, and this also. So these are total number of subarrays you have to compare with. So now check. Now try to find whether there are whether there are at least 3 numbers which are matching in the subsegment of my array A with array B. So how to solve this problem? So it is a pretty much classic sliding window type problem, but how? So I will simply maintain two maps in this question. Okay, two map, but how? What is the role of that map? I will tell you. Let's suppose first map will be mapping my array number B itself. Okay, that will I will call map of B. Map of B. Okay, my map of B will map my B array. Okay, great. Now what I'm doing, I will start iterating from my array A itself. Okay, from 1, 2, 3, 4, 5 till I match my first segment of size M, that is equal to 5. Okay, now I will also maintain a map B which is of another side, which will be only containing my current window, which will be, let me repeat, my map B is containing indexes of all the elements in map B. Okay, and my map A will be containing my mapped indexes of only segment of size M itself in the array A. Okay, my map A is a map for array A, which will be mapping each and every segment, or I can say mapping the segment in the sliding way of size M. Okay, so first of all, my map A would contain the mapping of only these 5 numbers, and my map B would containing a mapping of all these numbers. Okay, but now what to do? So for each and every case, I will try to find the minimum of both of them. For example, let's suppose I'm getting a 2 here. Okay, I will try to increase my count. Let's suppose I'm making a count variable which denotes the number of which denotes the number of matches in B and A itself. Okay, which denotes the number of matches in A and B itself. So if I'm encountering a 2, what I will do, I will simply add the minimum of map minimum of map B of 2 comma minimum of map A comma 2. So you tell me what would be the answer? So in my array B 2 is not there, so it will be always be equal to 0. It will never contribute in my answer. And my map A of 2 is equal to 2 definitely, because there are two twos in my array A in the first 5 numbers. But it will not impact because my minimum of B is equal to 2 only. So my count will not be increased in this case because my map it doesn't contain 2. So I will never update it also. So but next, here's it. For example, I'm encountering a 10 now. Okay, I'm encountering a 10. So that's a crucial point. So I will try to increase my count by minimum of map of A comma 10 comma map of B comma 10. So what will be added? My 1 will be added because my in my map A my 10 is coming one time, in my map B my 10 is coming one time. So minimum of 1 comma 1 is definitely 1 only. So I will simply increase my 1 in my answer. Okay, I will simply increase 1 in my answer. So but it's that sufficient, but I have no, it is not sufficient because I want a total number of 3 numbers which should be matched, but here is only one number which is matching, so I will never consider this case. So I will move my subarray further. Okay, but how further? Let me take now example of this subarray in which my answer is matching 2 to 2. Let's suppose taking this subarray. So in this question, my 10, 9 and 7, but 10, 9 and 7, each of these numbers are occurring once in my array A and occurring once in my array B also. So total number of 3 count will be increased eventually at the end of my 7. So I will check whether my count is greater than or equal to 3 or the minimum number required. If it is there, then I will simply increase my count because it is a subarray which is satisfying my answer. So that's how you can solve this problem. So if I show the code is also easy, not a big deal. So what I'm doing, I'm simply maintaining two maps, map A and map B. Okay, now what next? Simply mapping the array B with map B itself. Okay, great. Now I will simply try to increase my frequency. First of all, I will decrease the effect of my older frequency of my current number. Okay, I will decrease. Now I will increase my map of A by 1 and increase the count by minimum of map of A of I, minimum of map of B, comma A of I. But there is a catch. Like if my number is occurring in array A itself and it is not occurring in array B, then it will never be increased. It will never be increased because array B will always be give 0 to me if it is not there in my array B. Okay, so if my I is greater than M, which means I have encountered my first window of my size M. So in this question, I will simply decrease the effect of I minus M and simply decrease it from array A itself and increase the new effect of my previous number in my map of A. Okay, so if my I is greater than M and my count is greater than K also, then I will simply increase my answer that represent the number of subsegment which are giving me the right answer or giving me at least K numbers which I can find. So that's how you can solve the problem number D also. So let's now discuss problem number E. So for problem number E, I haven't coded it myself, but I will tell you the illusion how you can solve this problem. It is a pretty much greedy problem, not that much big. I will surely try to upload the code also later, but I will try to tell you the intuition firstly. Let's suppose it is a string. Okay, so in this question, I will tell them the minimum length of substring possible such that if I choose that substring and invert the numbers. For example, if inverting means like 0 to 1 and 1 to 0, and try to invert the numbers, then at the end I will always try to get the all ones in my binary string. So that is what questioning asking you to asking you to do, finding the maximum length of k such that at the end you can eventually get the all ones by reverse operation. For example, if you're selecting a subarray of size selecting a subarray of size 3. Okay, selecting a subset of size 3. So it will become 1, 1, 0, 0, 0. Now by selecting this, now it will become all ones. Yes, great, all ones. So that's how you can solve the problem by choosing this approach. So, but how to deal with each and every case? So in this question, you can clearly say, I can simply use an n-square approach. Okay, I can simply use an n-square approach. But how n-square will work? So there's a first of all greedy approach, greedy solution. Like first of all, I iterate from all the n's till 1. And that represent the current size of k. But how to deal with a current k, which means I'm giving you a k, and you have to tell them whether it is possible to assign all the ones which using the length of k, and you can only use a n or log n approach, n or n log n operation to perform the answer. But how you can do this? So you can use a pretty much brute force approach. Let's suppose I'm taking a 3 here only. Let's suppose here it equals 0, 0, 1, 0, 0, and my k is equal to 3 in this case. But how to solve this problem? So first of all, let's suppose you are encountering a, first of all try to start from left to right case. If you are encountering a 0, you have to always make it 1. There's no other option. You have to always make it equal to 1. Okay, I will try to make it equal to 1. So on the first index, increase the value by 1. Okay, and decrease the value of plus k, decrease the value of plus k plus 1, decrease the value of I plus k plus 1 to minus 1. Let's put equal to minus 1. Okay, I am telling you what's the logic behind this. First of all, maintain an array like this, which is eventually equal to all 0. And if you are getting a 0, then simply increase 1 here and simply decrease the k plus 1 value by minus 1. Okay, now also try to take a prefix sum. Okay, but how? Let's suppose there is a prerequisite, like you must have heard about line sweep. First of all, try to read about line sweep before reading this question. It's a pretty much comparable approach by line sweep only. Now take a prefix sum. Okay, so initially this value equal to 0. Okay, this value is equal to 0. Now you have to take a prefix sum. By taking a prefix sum, this value will also become equal to 1. Okay, this value is also become equal to 1. Now if my value is equal to odd, which means there's an operation which I performed earlier. Okay, there's an operation which I performed earlier. So in this question, so in this particular index, you will invert that value. So if it is equal to odd number, you will invert the value. Okay, great, invert the value. Now by inverting 0, it will equal to 1 only. So that's the case. So that's equal to this. So if it is equal to 1 only, then there is no need of performing the operation. Yes, there is no need of performing the operation. Now what next? I will now come to this index. Now taking a prefix sum as it is, I will make it equal to 1. Okay, I'm making it equal to 1. So now what? By making it equal to 1, I have to again reverse the 1. So by reversing the 1 it will become equal to 0. But now there is a case, like if I'm encountering a 0, I have to definitely make an operation. So by making a operation on this current 0, but I will simply add 1 here. Okay, I'm adding a 1 here. Now there is a no k plus 1 index, so I will do nothing. Let's suppose for the reference I will making it equal to minus 1, but there is a no need of doing this. Okay, now here now you can see it is now becoming equal to 2. Okay, now my prefix sum has become equal to 2. Now adding the 2 in my minus 1, is eventually 1 only. Okay, great. Now if it is 1, I have told you, if it is equal to 1, you have to reverse the current index. By reversing the 0, it will become equal to 1 only. Okay, great. Now again, now carry on the prefix sum. Now my 1 will be also carried to next index. That is equal to 1 also. Now you can see, if it is equal to 1, you have to reverse the operation. That is my 0 will become equal to 1. Okay, my 0 is becoming equal to 1. Now you can see my all the numbers are equal to 1 at the end by using the k is equal to 3, because you can see first of all, first operation I've used here, second here, because this operation is automatically reversed by the prefix sum only. And by this one has reversed to 0, but by performing the operation again, I have again turned this 0 equal to 1 only at the end only. So at the end of the operation, all the values are equal to 1. So that's how you can do this problem. First of all, read the line sweep before jumping to this solution, because this much how related to line sweep only. But the approach is simple. Simply, if you are encountering a 0, make it equal to 1 and also get the prefix sum. If your prefix sum is already 1 or already odd number, then inverse the bit. If it equal to even number, then don't do anything. Just keep it as it is. But if you are keeping it as it is, check whether the current index equal to 1 or 0. If it is equal to 1, then don't do nothing. Just move to the next index and carry the prefix sum. But if my prefix sum equal to even only, and your number is equal to 0, then definitely choose the operation and make your 1 equal to 0 equal to 1. So that's how you can solve the problem very easy also. So hope so you have got the solution of the problem very easy also. I will try to upload the code later. So if you have any doubts in any of these 5 problems, you can comment me down. And till then, stay tuned for the next one. Thank you.